Mm. This is Mukesh. I'm pursuing my master's in data science in University of Massachusetts at Dartmouth. In this video, I'm going to explain my project, that is ingredient detection and recipe assistant. First, what is this project? The idea is to build a system that can recognize ingredients from the pictures or the images. I used a deep learning model for this and connected it to a web app. The system can take inputs in three ways. You can type the ingredient, say it using your name, or upload an image. Once the ingredient is detected, the system shows the recipe suggestions and even guides you by step while cooking. Next, why? Why do we need this? The problem I wanted to solve is simple. Many people have ingredients at home but don't know what to cook. Searching for recipes online takes time. So I built a system that can quickly detect the ingredients and show the recipes simultaneously and automatically. The goal is here to make it easy and fast for anyone to use. Next, objectives. How are we solving it? As I already told you that I'm going to use a deep learning model, which is a CNN model here. I have taken 98 different ingredients and divided into 98 ingredient classes. The system can handle both common and rare ingredients right now. And I also built a front end where the users can give input through text, voice, or image. Then the app connects to the recipes and cooking mode will be displayed where it explains each step clearly. Next, what is my data set here? Uh, there's no particular data set where I have collected here because I have collected the images from Google, from the Google, and some of the images from the RoboFlow, and I have compiled all these images uh, in a separate folder where I have divided the folder names. A tomato, potato, or a cucumber, apple into these different classes. Different folders, and each folder has its own images in it. So what metadata consists is it has 98 classes with about 18,500 images, and around 30% of the images were used for validation and testing purpose. And I have resized each image by 224 by 224 pixels, and the training is done by small batches of 32 images at a time. What is the data pre-processing we have done here? We know that before training, the image had to be prepared. So I resized them, normalized the pixel values, and used data augmentation. Here it means that we are just creating a slightly changed versions of images by like rotating, flipping, zooming, or shifting them so that the model learns better. So I use the Keras data generator for this, and the data is split into training, validation, and test sets. So what did I use here? Which model did I use? I used MobileNet V2 as a base model because it's light, fast, and accurate. On top of it, I added three more layers, a pooling layer to shrink features, a dense layer with 128 neurons to learn patterns, and a final softmask layer to give probabilities for each class. So what are these layers and what is this MobileNet V2 layer? There are many convolutional layers in the stacked inside MobileNet V2, and early layers detect basic patterns like edges, colors, or simple shapes. But the middle layers detect more complex shapes like circles, textures, tomato skin or onion rings, etc. And the deeper layers detect object-like patterns, that is, red round object, it may be apple or tomato, long green object, it may be cucumber or zucchini, and etc. But for our model, first we are freezing these layers. We are only going to use the layers which we are going to add. The three layers which we have added is the global average pooling. What it does is it just squeeze down everything into a single vector. It changes the 3D to a single dimensional one. And the next layer we have added is which consists of 128 neurons. That is the ReLU layer. It means the rectified linear unit. Um, it is used to help the model to learn more about the patterns. It learns the combinations of features. That means if for example, one neuron may respond strongly to red and round, It means it may be apple or tomato. Or another neuron may respond to brown and rough. Uh, it may be potato or a small walnut. It's also possible for the walnut. And the last layer which you have read is softmax layer, which assigns one neuron for each ingredient class. This helps us to give us a probability whether the image is the ingredient or not. So this layer helps us to give an output for a tomato image as tomato as 0.95 or onion to 0.02. It may uh, predict and give a probability range. So what is the training strategy we used here? So I trained the model in two phases. In the first phase, I froze the MobileNet base model and only trained the new layers which we have added. In the second phase, I unfroze the last 20 layers of MobileNet base model and trained them again with a smaller learning rate. So this way, the model learned specific ingredient features while keeping the useful knowledge which it had obtained before. Let us jump into the code first. So this is my code for the training the model. This is where my ingredients are present, the images of ingredients. I have resized the images to 224 by 224 pixels and the batch size are given as 32. And I created a new directory and saved all the results as the plots, which we are going to get here in the model metrics folder. I mean, as you can see, I have used the image data generator here, and I have given the data augmentation here. I mean, rotating, shifting, zooming, etc. And I've shuffled these images in the training data set so that we can get so the model can go through more images. And I have the index of each image is stored in the JSON file for easy access. And for the validation test generator, we are not using any augmentation methods. And we have taken 70% of data to training and 30 to this validation test. And in this validation test, we have taken 50% of validation, 50% to testing process, testing sets. And we are not shuffling any of the data here, any of the images here. That's why we kept the false here. So this is our main base model, the model which we are going to use here. So the MobileNet V2, we are going to freeze all the layers in the MobileNet V2, including the top one, the top layer of the MobileNet. And as you can see, we have used our three layers, the gap that is global average pooling 2D, which converts 3D to single dimensional, the dense 128 neurons with the ReLU that is it's used to learn the patterns, and the softmax layer, which gives us the probability of each ingredient. What is this callbacks? We use a term, I mean, we used a function called callback here, early stopping. Uh, this is used this is used to stop the epochs if if it's increased if the value the accuracy, the validation accuracy does not increases or does not change after 5 epochs or every 5 epochs. It means that you are checking the validation accuracy for every 5 epochs, and if there is no change in the validation accuracy, then we can stop the epochs as there is no use of continuing the epochs after the validation accuracy is stagnated. So we are given the epochs as 30 here. When I try to run this code, it went only through around 15 epochs. After 15, it got stopped. The validation accuracy did not change anywhere. And for the here, the phase two, we have unlocked the last 20 layers of base, I mean the MobileNet V2, and run this code, tune this model again for using these last layers. And we have used the same early stopping and model checkpoints here. And uh, this is we have saved this in a H5 format. This is our code as of now, and we got the accuracy of around 98%, and yeah, and we got around 90% of validation data. That means it learned well, though there is a little bit of overfitting. Most classes had a very good performance here, as you can see there. And coming to last results, the training loss dropped down to 0.03, but the validation loss was higher, about 0.65. This gap shows that the model fits the training data, but it it's somewhat difficult to it struggles a bit on the new data. So we need more augmentation or some regularization is helpful here to fix this. I couldn't show all the classes here because it's more than around 100 classes. So I just took the bottom 20 classes by the F1 score. And while we check class by class, even you can see that even the weaker ones have F1 scores of about 0.8. But some classes like olive oil, walnuts, or dragon fruit do not perform very well because there are few images in it. So the system architecture. I mean, how does my web app or the system work here? We can enter this. You can enter the ingredient using a text, or you can use a voice, or you can give an image to the web app, and the Flask at the back end receive the input. And if you give an image, the image goes to model to predict the ingredient. And once the ingredient predicted, and the name of the ingredient is given back. It goes to the recipes and search for the ingredient name in it and displays you the recipes which has the ingredient in it. So, so and what other features I have added here is I try to do a hands-free model. So for that, I included the voice input ingredients, and when the recipe is started, the steps are displayed step one by one, and it will be read out loud so that as a voice guidance. And you can control the steps using your voice, like next, previous, back, or to move the step to the next or the previous. And I also added a timer, so you can just start a timer for 5 seconds, and the timer goes on for 5 seconds. And added some modes here. I mean, if you want a spicy mode, lazy mode, and party mode, which I have added. These are some basic modes where spicy mode has most of the spicy recipes. Lazy mode has the recipes which take time less or which is not difficult to make. And the party mode has the recipes which is used for the party big recipes, the complex recipes. And let us dive into the code. I mean, the basic app where we are using it. So this is the app.py which I have used here. And you can see that we are loading the recipes. I used the fuzzy logic to, what can I say, to search for the ingredients name in the recipes. And you can see that you're using the post method, get method here, and all the routes. These all recipes route displays all the recipes gets the recipes from the JSON to your web app. And this predict one is, it's used to predict the image which is given to the web app. So let's run this code. Do it in. Oh, so this is my um, just a minute. Yeah. So this is my web app which I developed. This is the normal mode. This is the dark mode, and you get spicy, spicy mode, lazy mode, and party mode, and each have its own dark modes here. And so uh, I can type here the onion and search for the recipes, and it shows all the recipes which in this web app. Or I can use the voice recognition onion. So, or you can also use tomato. If you get recipes, you can see the recipes here. And for the images, I think you can choose the images too. So let's suppose we'll take this image. So if you get chicken, so it's chicken. You get the chicken recipes here. The same way, mm, it may be anything, onion, or and for the similarly for the spicy ones, you get only the spicy ones here. What I done was I created a new text separate text files for this and uploaded the spicy recipe names in the spicy text file, spicy mode text file or the lazy mode text file in the backend. And so when I click the recipes, it just shows us you can see the ingredients required and the instructions. When I click the start cooking, so we can get step by step. Next, repeat, exit. It goes out, and you can also use a favorite, or you can bookmark your recipes here. And yeah, then what are the limitations here? Uh, you can see that some of the ingredients there are so, some of the rare ingredients are from a bit worse because of a fewer samples, and there is some overfitting here. And the system currently detects only one ingredient per image, and it can't detect multiple ones. And yeah, and for the future work, we can use more advanced data augmentation methods. And I wanted to use techniques like class weighting or uh, focal loss to handle the imbalance. And I wanted to make the model to detect multiple ingredients at the same time in the same picture. And we can also shift this whole web app into mobile device so that it's easily available to take a picture using a mobile phone. And we can also integrate any chatbot here so that it's usable to converse with the bot and know more about the steps. So, uh, so to sum up, I built an ingredient detection model using the MobileNet V2, and that achieved over 98% accuracy. And I integrated it into the web application where users can give input via text, voice, or image, and you can get the recipe. Sorry, listen from there. And that's all about it. I think we can still improve further with some more future updates. Thank you.